With field-centric controls, when I push this joystick away from me, the robot goes away from me, regardless of which way it's faced.
Alright, so right here we're getting the z-axis of the robot, so whatever like orientation the robot's in, it's going to know it's going to give us it in an angle right here. And we're going to use that angle in all the program down here. These are all of our variables, right? These are our drive variables. These are the things that make this work. So right here, this is a turn. This is just your left stick. So as you turn the left stick, it's just going to turn the robot. It's pretty simple. This is the drive. We're going to clip the drive into a range clip. So how this works is we take the square root of the right stick, right? Both the right stick x and y. We're going to take it from the Pythagorean theorem, right? And we're going to clip it. So it's going to give us a value between 0 and 1. Okay?
Yeah.
Yeah? Alright. Then we're going to get another variable, right? Called gamepad degree. And we're going to take the inverse tangent of the negative of the right stick y and the right stick x, right? We use this to see the degree, like the angle that the right stick is pointing at all times. And we're set that to gamepad. And then the next variable is movement, right? The movement is just okay, so the movement is the actual movement. It takes. Wait, hold on, what's this do? Hold on. Movement. Gamepad degree minus.
It makes it strafe.
Oh, okay. So the movement right here, what this does is it takes the degree of the gamepad, so whatever degree that you're turning the right stick, right? It subtracts that from the degree of the actual robot. Right over here. To kind of give it like a fake front, right? So this is going to tell you, this is going to tell the motors what power to give it in order for it to go straight. This is the strafe and the forward. They're basically the same thing, except for the cosine and sine. And basically that's just like, this is front and back, this is left and right. And you set those to a variable too. And then all this stuff gets thrown up here, okay? This is the actual movement. These are the powers of the motors, right?
Yeah.
And so this is what you're setting the powers of the motor to. And so for the left one, this is very specific. This equation right here, very specific. So you're going to take the forward, times it by the absolute value of the forward, right?
Yeah.
So these down here. You're going to take that and then add that to the strafe times the absolute value of the strafe, right? And that gives you a power. And then you're going to add that to turn. Because, like, obviously, if you're going to go forward and turn at the same time, you'd add this.
You obviously need to turn.
Yeah. So this is the right? The same thing. Forward times absolute value of forward. But when you come here, it's minus now. Strafe times absolute value of strafe minus turn. And then right here, back right, forward times absolute value of forward plus strafe times absolute value of strafe minus turn. And then the last one is back left, which is forward times absolute value of forward minus strafe times absolute value of strafe plus a turn.
Okay, now, yeah.
Alright, so first, we're going to make a new program called Field Centric Controls.
Obviously,
right?
okay.
We're going to use the sample of the sensor IMU, okay?
Okay.
I'm going to load that up. First thing we're going to go through, delete a lot of this that we don't need, like all the comments, all these comments. We're going to keep these and delete this, and keep those, and we're going to delete all the loop blocks, which have this run op mode, right? And this does basically for our robot, it just initializes the internal IMU to measure angles. So we're going to take a function and call it int IMU, right? We're just going to drag all this into here. So now, like once we started, our IMU will be initialized. So then we're going to take another function block with a return. We're going to create a variable. We're going to call it angle. Right, I'm going to drag that into here. So we're going to set an angle to the IMU. So we're going to go to our sensors, and IMU parameters. Wait, no, add this IMU. And then write out this one. And then we're going to do intrinsic, since it's like the actual IMU. And then this is varied on how the control hub is set up on your robot. And for ours, we're measuring the z-axis. So I'm going to switch this to this one, zxy. And we're going to do it in degrees. And the return on this, what we want is we want the orientation. So we're going to come down to orientation and to the first angle. So that's just saying we're going to get the first angle, which is z right here. We're going to set that to angle. We're going to call this get z-axis. Then next, we're going to make all of our variables, okay? All the things that are going to make it run. So we're going to do another function block. Bring that in here, just call it drive, since they're all the drive variables. Okay, so the first variable we need is like to actually turn the robot. Variable. Oh wait. I'm going to create a variable. Call it turn. And we're going to set turn equal to. We're going to use a math block because it's like. So we can slow it down or speed it up however we want. And get the gamepad. We're going to set to gamepad 1 the left stick. Yeah, or right stick.
That's the right
No, left stick. Yeah, you can just change it. And for ours, we just use 0.5, so it's like half speed of like the actual forward and backwards, so you can get like pretty precise turns, but you can change that as you want. Then we're going to get another variable. It's going to be our drive variable. And what this variable does is we need how far up the joystick is pushed, right? So we can see like how fast or how slow, like how much you're actually like throttling the thing. So to get that, we have to use the Pythagorean theorem. So we're going to use a range clip. We go here, range clip. We're going to do that between 0 and 1, so we don't get any negative numbers. And then we're going to clip the square root of the right stick x by the right stick y. And the right stick x and the right stick y. But it's d squared, right? So it's right stick squared plus left stick squared. I mean, y squared. And that's just going to give us how much like throttle you're giving the actual robot. So you have more precision. Then we're going to make another variable called gamepad degree, right? Take that. And that's just telling us like what degree you're actually like rotating the y stick or the x stick. So what that is we get that by the arctangent of the x and y of the right stick and left stick. So how you do that? You're gonna get like the right stick and left stick. Left stick, right stick, x, and right stick, y. This is y. And the way this is set up, you have to make this negative. So we're going to go in here. Yep. Oh, negative. There we go. And so now we have the degree that you're rotating it and how much you're rotating. I mean, how much you're pushing it forward. And then next, we're going to make another variable. I'm going to call it movement. And in this variable, it's basically saying what's the difference between however much we're rotating it and the actual orientation of the robot up here. So the way we do that, we're just going to take these two, so like gamepad degree, right here, and subtract that from this output right here, the get z-axis. So then that's going to give us like the angle that we need, or the actual angle that the robot's turn. We're going to make two more variables, the strafe and forward. Strafe, and this is just basically the left and right and the front and back movement, but strafe is left and right. So the way we do that, we're going to get multiplication. We're going to times this. We're going to times the movement by the drive. So whatever angle, whatever angle it should be by however much you're pushing it. So, variables, movement, and the drive. Oh, it should actually be the cosine of movement, yeah. Right. Where's cosine? Right here, right here. And take the cosine of the movement times drive, and then we'll make another variable called forward. Forward. And this is just going to be the front and back. But on this one, we're going to use the sine of the movement by the drive. So sine of movement times that by drive. And so that's all the variables you pretty much need. So now we actually do all the movements for like motor powers. So first, start that off. We're gonna switch the orientations of our motors because our motors are set up. So we're gonna reverse the back left motor and the left motor since they're actually flipped on a robot. So left and back left. And then now we're going to call this to initialize the IMU. So we're going to come down here to functions and call it to initialize. Now we're going to call the program, wait for start. So right when we start now all this happens. Now we're going to take and if you, and we're going to repeat and repeat while. And come back up here, make sure if the thing is activated. And while, yeah, while it's activated. So there we go. So while this is activated, we're going to get all of our drive functions. They're going to be constantly updating. So we're going to take this, put that in the while, and then we're going to take our 4 motors. So our 4 DC motor. We're going to get these. That's 1. All 4 of them. Left, right, and back left. There we go. Now we have to do this long equation to actually get like the motor powers. So we're gonna come down here to math. Take this add. So how this works is we have to take the function, the forward variable, and times it by the absolute value of forward. So right here, drag it in here. So forward times absolute value of forward. absolute value forward plus the strafe times absolute value of strafe, so we get variable strafe times absolute value of strafe. Get our absolute value. So this gives us the actual power for the left motor right here. But since we want it to be field centric, we want it to be able to turn while it drives. So we're going to take all of this and add it to the turn variable. Drag all this in here and add this to our turn. And these are all going to be the same except for a few changes in the signs. So the next one is right? So it's forward times absolute value of forward. Then we're going to subtract it instead of adding. So it's the right, so it's flipped. And then we're going to subtract the turn as well. The next one is back right. Forward times absolute value of forward. It's going to stay the same, but this is going to be flipped on the turn. It's on the right side. And lastly, the back left, which is going to be negative. It's going to stay the same.